In this video about compound interest, we're going to develop the compound interest formula. Given a compound interest problem, determine the goal and identify the given information, and finally, use that compound interest formula to solve for unknown quantities. Let's first talk about the difference between compound and simple interest. With simple interest, interest is earned once at the end of the time period. So if we have a situation where we've got $1,000 that's invested at an interest rate of 3%, and our time period is 5 years, then our interest is going to be earned at the end of the 5-year time period, and our future value is going to be $1,000. After 5 years, we end up with $1,150, and so we can see from this that our interest was $150. All I did was I took the 1,150, subtracted off the 1,000. This interest was earned. It was added to our account after the 5-year period. Now, the difference with compound interest is with compound interest, the interest gets earned every period. So interest is earned. Maybe it's earned every month, maybe it's earned every 6 months, but interest is earned and then it's added to the account at the end of that time period. So if we're earning interest annually for a period of 5 years, just like we had down here, then at the end of every year, we'd earn interest and that interest would be added to our account. Then, when the interest is calculated for the following year, we'll be earning interest on the original principal value in addition to earning interest on the interest. So compound interest tends to grow at a much quicker rate than simple interest. Let's develop the formula for compound interest. Remember, from simple interest, we know that the future value equals present value times 1 plus RT. And let's again look at $1,000. This time let's look at an interest rate of 4%. How much would be in the account after 1 year? Well, after 1 year, this is just the same scenario that we've been working with. We're going to take our $1,000 and add and multiply that by 1 plus 0.04 times 1. So I've got 1,000 times 1.04. So this actually turns out to be $1,040. We're not actually going to use that quite yet. Let's look at what happens after 2 years. So the second year, we're starting out with that $1,040 in our account, not just the $1,000. So when we go to earn interest, we're earning interest on that extra $40 that we've earned. So our future value is going to be the 1,000 times 1.04, this is our present value, times 1 more year of interest gets earned. That's what this does. And so after 2 years, notice that we end up with 2 copies of that 1.04, and so we end up with 1,000 times 1.04 squared. This turns out to be $1,081 and $60. Now notice, the first year we earned $40 in interest. Now, in the second year, we've earned a total of $81.60 of interest, but the second year we earned $41.60 instead of just the $40. So the amount that we're earning in interest is increasing in addition to our total value. Let's guess what happens after 3 years. If after 2 years our exponent here is 2, after 3 years it's going to be 3. After 12 years it's going to be 12. If we look at the 12-year value, we end up with $1,601.03. So now we've earned $600 in interest, over $600 in interest. If we look at more generally, after t years, we're going to have an exponent of t. So let's see what the actual formula is for compound interest. Let's look at our compound interest formulas. Before we look at the actual formulas, let's talk about what the variables represent. So in simple interest, we had future value and present value being FV and PV. Those are the same as it is in compound interest. We also had time is our T, and this time is in years. It's always in years. And our R is our annual interest rate. Now, this annual interest rate, that annual part is important. We always have to be thinking, is this the annual interest rate or is it something else? New in this type of interest is our M, which is our number of times per year interest is compounded. So in the last example, we were looking at that $1,000 that was earning interest every year, and the interest would be calculated and added onto our account. Well, we could have interest that's earned every month, or we could have interest that's earned every quarter. So we need to keep track of how many times per year that interest is compounded, and that is our value of our M. M times T, this is the number of compounding periods over the lifetime of the deposit that we're talking about. Now let's look at the actual formulas. So this is our formula. We have future value is present value times 1 plus R divided by M to the MT. Now notice that this R divided by M, when we were developing the formula, we just had the R there. That was because our M was 1, because we were compounding annually. And MT, this is the number of times we're compounding, or the number of compounding periods. So this should look fairly similar to the simple interest, but now the important thing is we've got this exponent here. Now sometimes our scenario will be that we are looking for the present value instead of the future value. And so two ways that we can write that present value formula is we could write it with as a fraction. So present value is future value over 1 plus R over M to the MT. Or we could take this bottom part, that denominator, and move it up to the numerator. And when we move it up to the numerator, it's going to be future value times 1 plus R divided by the M to the negative MT. Now, I mentioned in the last slide that sometimes we change how we compound. So some common compounding periods are we could compound annually, so that's 1 time per year, so our M value would be 1. We could compound biannually, so this is 2 times per year. Sometimes people interpret that as every other year, but this is actually 2 times per year. We could compound quarterly, so that's 4 times per year. And another way quarterly is said is every 3 months. That means the same thing. We could compound monthly. There's 12 months in a year, so that would be M equals 12. We could compound weekly. There's 52 weeks in a year, so that would be M equals 52. We could compound daily. Sometimes when we're compounding daily, they use 365, or sometimes they'll say use 360 for the number of days in a year. We could also compound every minute. We could compound every second. In general, if we keep the same interest rate, but we increase the number of times per year that we're compounding, the future value goes up. But it's surprising how little difference here that there's a huge difference between once per year and 12 times per year or 52 times per year. But as we get in this lower half here, there doesn't end up being a huge difference in the end result. Let's look at an example. In this example, Corey discovers he accidentally overpaid in taxes this year and is due a $2,500 refund. He decides to save the money, so he's not going to take a trip to Cabo. He's going to save the money, and he's going to put $2,000 of the money into a CD and another $500 into an index fund. So an index fund, this is just a type of investment where you can purchase a grouping of stocks that tracks how the market is doing in general. So it doesn't earn interest, but it does have a historic growth rate that we can use to estimate what we think it's going to be worth in the future. Now, since we have two different types of accounts that we're earning money in, we're going to need to do two different future value calculations. Let's look at what information we're given for the CD. For the CD, we know we're investing $2,000, so my present value is $2,000. So I'm writing down all my given information. And it's a 5-year CD, so that tells me my time is going to be 5 years. My interest rate is 2% per year compounded daily. So my R is 0.02. That's how we write 2% as a decimal. And if it's compounded daily, this tells us our M, the number of times per year that we're compounding, is going to be 365. My goal is to find the future value. Remember our future value formula. Future value is present value times 1 plus R divided by M to the MT. If we substitute in our known values, we're going to have our future value is 2,000 times 1 plus 0.02 divided by 365 to the 365 times 5. Plugging this into the calculator, we end up with $2,210.34. Now, one thing to notice is we had started out with $2,000 and we now have $2,210, so I can very easily see that the amount of interest that we earned was $210.34. I don't actually need to know that, but it's something that you might be asked in another scenario. See if you can calculate the future value for that $500 that's invested in the index fund. Did you pause the video? Here's what I had. For the index fund, our present value is $500, our time is 5 years, the growth rate is 8% or 0.08, and the number of times per year that we're compounding is 1. The reason why it's 1 is it says it's compounded yearly. Here I have my compound interest formula, then I've plugged in my known values and calculated the results on my calculator. I end up with $734.66. Now, our original question was to find how much money will he have in 5 years. So we want to know the total amount of money that we have. So our total is this $2,210.34 plus that $734.66. We end up with $2,945. Now we ended up with just an integer value. We don't typically, it shouldn't end up being, 0.00 each time, but this time we did, just a fluke. Let's look at another example. In this example, Sachi wants to be earning an annual salary of $90,000 per year when she retires in 10 years. She's been offered a job that guarantees an annual salary increase of 4% per year. What salary should she negotiate in order to meet her goal of $90,000 when she retires? We're supposed to round to the nearest dollar. So first, let's think, is this a compound interest situation or is it just a regular simple interest situation? Suppose she started out with a salary of $50,000 per year. This is not what she's going to negotiate, but let's just suppose that this is the case. After 1 year, she's going to earn a 4% raise, and we would calculate her new salary by taking that $50,000 and multiplying it by 1.04. So she'd end up earning $52,000. Now, the following year, she'd be starting with a salary of $52,000, and then she'd earn another 4% raise again. And so she would be earning a raise on that $52,000 salary. So then the second year, you'd have to take the $52,000 times 1.04. So this is exactly how compound interest works. She started out with the 50,000. She's earning 52,000 the second year. When they compute her raise for the third year, they're going to multiply that 4% times the 52,000. So she's earning 4% not only on this 50,000 here, but she's also earning that 4% on the $2,000 raise. So this is compound interest. So let's see if we can figure out what's going on. Sachi wants to earn $90,000 per year when she retires in 10 years. So thinking about our given information, we know we're talking about a 10-year period, and the $90,000 is what she wants to earn at the end of 10 years. So that $90,000 is my future value. We also know that she's guaranteed a salary increase of 4% per year. So my R is 0.04 and my M is 1. Now the reason why the M is 1 is because she only gets that raise one time each year. If she got a 4% raise every 6 months, then our M would be 2. My goal is to figure out how much she should negotiate for her salary when she gets hired. So that is the present value of her salary. If we write down our compound interest formula, we would use that present value version. So I'd have present value is future value times 1 plus R divided by M to the negative MT. Plugging in what we know, future value is 90,000. We're going to have 1 plus 0.04 divided by 1 to the negative 1 times 10. When you input this into your calculator, you end up with $60,800.78. But they told us they wanted us to round to the nearest dollar. So if I look at my number here, this 0 here is the dollar place. So my answer should be $60,801. I went ahead and rounded up since this number was 5 or larger.